Okay, last example, example 7. Now this one's pretty tricky, okay? This one's a little bit tricky, so you're going to have to think. So feel free to pause this video and just think through what this solution might be, all right? Find the equations of the tangents to y equals x squared from the external point to 3. Okay, let's think about what this means. I need to find the equations of the tangent. So there might be more than one line here that I'm dealing with. But the original function is y equals x squared, so it's just a regular parabola. I have a point 2, 3 that's external, which means that it's not going to be on this graph, obviously, because if I put 2 in, I get 4 out, and that's not 2, 4, that's 2, 3. Okay? So 2, 3 is the external point, okay? Something like this. It might be over here, and I might have two tangents, probably two, okay? I would expect probably two tangent lines that would touch the graph of y equals x squared, okay? And I need to find what those are, okay? So let's start with what we do know. We know that the lines are going to pass through this point. Okay, the tangents must pass through the point 2, 3, so we could probably use this later on, probably with point slope form or some other form, okay? But that's useful information. Okay, so now I need to find the slopes of my tangents. Well, how do I find the slope of the tangent? Well, I can find the slope of the tangent at any point if I find the derivative of my original function. So let's find the derivative. Y prime is 2x. That's going to be the general derivative function. Okay? But I have a problem. I do not know at exactly which point on this curve my tangent lines are going to be touching. So I don't know the point of tangency. So here's what we're going to do. We're going to let x be some variable a. Okay? Well, let's say it's a constant a. Alright? And if this is true, then the tangent, is going to be y prime evaluated at the point x equals a, which, since it was 2x, if I just put an a in here, it's going to be 2a. Okay? So let's just leave it like that for now. What is the point of tangency? Well, since I let x equal a, the y value that corresponds to that should be f of a, right? And since I know f of x, which is x squared, we could say the y value is going to be a squared. So I'm going to have an a and an a squared as my point of tangency. Alright? I can still, let's see, I found my slope, I found my point of tangency. What am I missing? Well, technically I could find the equation, but I would have an a in there, right? I would have an a in my equation. So I have to use something else, and it turns out I can find what this, I can find what a will be since I know x and y. I have another point that I could substitute into here. I have the point 2, 3. I know it's going to pass through. I know the point 2, 3 is going to be passed through by the equation of the tangent line. Okay, so we're going to use that information to help us. So I substitute in 2 in here and 3 in here and solve for a. And if I can solve for a, then I can come back and answer my question, which was find the equation. Okay, then I can use this again to find my equation. So 3 minus a squared is 2a times 2 minus a. I end up with a quadratic. If I simplify that, I get a squared minus 4a plus 3 equals 0. A minus 1 times a minus 3 is the factored form, so I have two answers. I have a equals 1 or a is 3. Alright? And if I plug those values back into here, I could get, if I plug 1 in for a, I get the equation y equals 2x minus 1. If I plug in 3 into my form, I get y equals 6x minus 9. Okay, so there you go. Those are the two tangent equations that pass through the point 2, 3. Okay, so feel free to rewind and rewatch this as necessary, but that's probably a little bit more of a critical thinking type question. All right.